Azure Storage accounts serve as the foundation for data storage in the cloud. These accounts provide a unique namespace for your Azure storage data, accessible from anywhere in the world over HTTP or HTTPS. This global accessibility ensures that your data is always within reach, regardless of your location or the devices you're using. Security is a top priority when it comes to cloud storage. Azure storage accounts are designed with robust security measures to protect your data from unauthorized access. Additionally, these accounts offer high availability, ensuring that your data remains accessible even in the face of hardware failures or network issues. Durability is another crucial aspect of Azure storage accounts. Your data is replicated multiple times to prevent loss due to hardware failures or other issues. This replication strategy ensures that your data remains intact and recoverable, even in worst-case scenarios. One of the most impressive features of Azure storage accounts is their scalability. As your data needs grow, your storage account can easily expand to accommodate terabytes of information. This scalability allows you to start small and grow your storage capacity as your business or application demands, without worrying about running out of space. When creating a storage account, you'll need to choose the account type. This decision is crucial as it determines the available storage services and redundancy options. The account type also influences the use cases for which the storage account is best suited. Azure storage accounts offer a range of redundancy options to ensure data durability and high availability. These options cater to different business needs, balancing factors such as data protection, accessibility, and cost. Locally redundant storage, or LRS, is the most basic option. It replicates your data 3 times within a single data center in the primary region. While this option provides protection against hardware failures, it's vulnerable to data center-level disasters. For businesses requiring greater data protection, Geo-redundant storage, GRS, offers an excellent solution. GRS replicates your data to a secondary region hundreds of miles away from the primary region. This approach safeguards your data against regional outages or disasters. Read Access Geo-redundant storage, RAGRS, builds upon GRS by allowing read access to the data in the secondary region. This feature is particularly useful for maintaining high availability of your data, even if the primary region becomes inaccessible. Zone Redundant Storage, ZRS, is designed for scenarios requiring high availability within a single region. It replicates your data across 3 Azure availability zones in the primary region, providing resilience against data center failures. For the highest level of protection and availability, Azure offers GeoZone Redundant Storage, GZRS. This option combines the benefits of ZRS in the primary region with geo-replication to a secondary region. Lastly, Read Access GeoZone Redundant Storage, RAGZRS, enhances GZRS by allowing read access to the data in the secondary region, similar to RAGRS. Each of these redundancy options comes with different pricing and performance characteristics. The choice between them depends on your specific requirements for data durability, availability, and cost management. Azure offers several types of storage accounts, each designed to cater to specific use cases and performance requirements. Let's explore these account types and their characteristics. The standard general-purpose V2 account is the most versatile option. It supports a wide range of storage services, including blob storage, queue storage, table storage, and Azure Files. This account type offers the most comprehensive set of redundancy options, making it suitable for most Azure storage scenarios. If you're unsure which account type to choose, this is often a safe bet. For scenarios demanding high performance, Azure provides premium storage options. The premium Block Blobs account is tailored for workloads with high transaction rates or those requiring consistently low storage latency. This account type is ideal for scenarios involving smaller objects or frequent data access patterns. The Premium File Shares account is specifically designed for file storage workloads. It's the go-to choice for enterprise applications or any scenario requiring high-performance file shares. This account type supports both Server Message Block (SMB) and Network File System (NFS) protocols, making it versatile for various file-based applications. Lastly, the Premium Page Blobs account is a specialized storage type for page blobs only. Page blobs are optimized for random read and write operations, making them suitable for scenarios like virtual machine disks. When selecting a storage account type, consider factors such as the type of data you're storing, how frequently you'll access it, the performance requirements of your application, and your budget. The redundancy options available for each account type also play a crucial role in ensuring data durability and availability. Remember, while premium accounts offer higher performance, they also come at a higher cost. It's essential to balance your performance needs with your budget constraints. In many cases, the standard general-purpose V2 account provides sufficient performance for most applications, while offering the most flexibility in terms of supported services and redundancy options. Azure storage accounts offer a unique namespace for your data within the Azure ecosystem. This unique namespace is a key feature that simplifies data access and management in the cloud. Let's delve into the concept of storage account endpoints and the important naming rules you need to follow. The endpoint of your storage account is essentially its address in the Azure cloud. It's how your applications and services locate and interact with your data. This endpoint is formed by combining two elements: your storage account name and the Azure Storage Service endpoint. For example, if your storage account is named My Storage Account, your blob storage endpoint might look like this: https://mystorageaccount.blob.core. Windows.net. The uniqueness of your storage account name is crucial. It ensures that your data has a distinct accessible location within Azure. This uniqueness requirement leads us to the important naming rules for Azure storage accounts. When choosing a name for your storage account, keep these rules in mind. First, the name must be between 3 and 24 characters in length. This range allows for names that are both memorable and functional. Second, you can only use numbers and lowercase letters in the name. Special characters and uppercase letters are not allowed. This restriction helps maintain consistency and prevents confusion that might arise from case sensitivity. Lastly, and perhaps most importantly, your chosen name must be unique within the entire Azure ecosystem. No two storage accounts can have the same name, regardless of which Azure subscription or region they're in. This global uniqueness is what enables Azure to provide that distinct namespace for your data. When you're creating a new storage account, Azure will automatically check if your chosen name is available. If it's not, you'll need to try a different name. It's a good practice to have a naming convention for your organization that combines unique identifiers to help ensure you can create unique names when needed. Remember, once you've created a storage account, you can't change its name without creating a new account and migrating your data. So, choose your storage account names thoughtfully, considering both your current needs and potential future uses. Azure Storage offers a variety of services, each designed for specific data storage scenarios. Understanding the endpoint format for each service is crucial for effectively managing and accessing your data in Azure. Let's break down the endpoints for each Azure storage service. Blob storage, which is optimized for storing large amounts of unstructured data, uses the endpoint format https storageaccountname.blob. Core. Windows.net. This service is ideal for storing files, images, and other binary data. Data Lake Storage. Gen 2, an enhancement of blob storage optimized for big data analytics, has a slightly different endpoint. https summate.storageaccountname.dfs.core. Windows.net. The DFs in the URL stands for Data Lake File System, reflecting its specialized nature. Azure Files, which provides fully managed file shares in the cloud, uses the endpoint https storageaccountname.file core.windows.net. This service is particularly useful for migrating on-premises file shares to the cloud. Queue storage, designed for storing large numbers of messages that can be accessed from anywhere in the world, has the endpoint https storageaccountname.queue.core.windows.net. This service is often used for creating a backlog of work to process asynchronously. Lastly, table storage, a NoSQL data store providing key attribute storage with a schemaless design, uses the endpoint https .g storage account name table.core windows.net. This service is useful for storing structured non-relational data. Notice that all these endpoints follow a similar pattern, with the service type blob, DFS, file, queue, table inserted between the storage account name and core windows.net. This consistent pattern makes it easier to remember and construct the correct endpoint for each service. When working with Azure Storage, you'll use these endpoints to configure your applications, set up access policies, and manage your data. The specific endpoint you use will depend on which storage service you're working with. For instance, if you're storing and retrieving large files, you'll work with the blob storage endpoint, while if you're setting up a message queue system, you'll use the queue storage endpoint. Remember, replace storage account name with your actual storage account name to get the full usable endpoint. For example, if your storage account is named MyStorage account, your blob storage endpoint would be https mysstorageaccount.blob.core windows.net. Understanding these endpoints is key to effectively leveraging Azure storage services in your applications and workflows. Azure Storage is designed with a robust redundancy system to ensure the safety and accessibility of your data. At its core, this system always maintains multiple copies of your data, providing a solid defense against a variety of potential issues. Imagine a scenario where a hardware component fails unexpectedly. In a traditional setup, this could lead to data loss or downtime. However, with Azure Storage redundancy, your data remains safe and accessible. The same principle applies to network outages or power failures, events that could otherwise disrupt your operations. But Azure's protection doesn't stop at everyday technical hiccups. The redundancy system is also engineered to withstand larger-scale events, including natural disasters. This comprehensive approach ensures that your storage account can meet its promised availability and durability targets, even in the face of significant challenges. When it comes to implementing redundancy, Azure offers a range of options. These choices allow you to tailor the redundancy strategy to your specific needs, balancing factors such as cost, data accessibility, and the level of protection required for your particular use case. When it comes to selecting the right redundancy option for your Azure storage, several key factors come into play. Let's explore these considerations to help you make an informed decision. First, consider how your data is replicated within the primary region. Different redundancy options offer varying levels of protection within a single region. This local redundancy can protect against hardware failures or network issues within the data center. Next, think about whether your data needs to be replicated to a secondary region. This geographic redundancy provides an extra layer of protection against regional disasters. It's particularly crucial for applications that require high availability and disaster recovery capabilities. Another important factor is read access to replicated data. In the event that your primary region becomes unavailable, some redundancy options allow read access to data in the secondary region. This can be a game changer for maintaining business continuity during unexpected outages. Lastly, don't forget to consider the trade-off between cost and availability. Higher redundancy levels generally come with increased costs. It's essential to strike the right balance based on your specific business requirements and budget constraints. By carefully weighing these factors, you can choose a redundancy option that aligns perfectly with your organization's needs, ensuring optimal data protection and accessibility. When it comes to Azure storage, data protection begins right at home in the primary region. Azure ensures that your data is always replicated 3 times within this region, providing a solid foundation for data durability and availability. This approach safeguards your information against common issues such as hardware failures or network glitches. Azure Storage offers 2 distinct options for data replication within the primary region: locally redundant storage, LRS, and zone redundant storage, ZRS. Each of these options has its own characteristics and use cases, allowing you to choose the one that best fits your specific needs. Let's focus on locally redundant storage, or LRS. This option replicates your data 3 times, but with a twist. All 3 copies are stored within a single data center in the primary region. This approach offers an impressive durability rate, ensuring at least 11 nines of durability. That's 99.9% of objects over a given year. In practical terms, this means that your data is extremely well protected against common issues like server rack failures or drive malfunctions. While locally redundant storage, LRS, offers robust protection against many scenarios, it's important to understand its limitations. LRS is designed to safeguard your data within a single data center. This means that while it's highly effective against localized issues, it may fall short in the face of larger-scale events. Consider, for instance, a disaster scenario such as a fire or flooding that affects the entire data center. In such a case, all replicas of a storage account using LRS could potentially be lost or become unrecoverable. This vulnerability highlights the importance of considering your overall risk tolerance and disaster recovery needs when choosing a redundancy option. Given these potential risks, Microsoft recommends exploring other redundancy options for scenarios that require higher levels of data protection. These alternatives include zone redundant storage, ZRS, which spreads your data across multiple zones within a region. 2. Geo-redundant storage, GRS, which replicates your data to a secondary region hundreds of miles away. 3. Geo-zone redundant storage, GZRS, which combines the benefits of ZRS in the primary region with geo-replication to a secondary region. These options offer increased protection against regional disasters and provide more robust disaster recovery capabilities. The choice among these depends on your specific business requirements, compliance needs, and the criticality of your data. This diagram illustrates the 2 primary redundancy options available within Azure's primary region: locally redundant storage, LRS, and zone redundant storage, ZRS. On the left side of the diagram, we see locally redundant storage, LRS. In this configuration, data is replicated 3 times within a single data center. This is represented by the 3 rectangles within the LRS box. LRS provides high durability against hardware failures and local network issues, but all copies are vulnerable to data center level disasters. On the right side, we have zone redundant storage, ZRS. This option spreads your data across 3 availability zones within the primary region. Each zone is an independent data center with its own power, cooling, and networking infrastructure. This is depicted by the 3 separate rectangles, each labeled as a different zone. ZRS offers higher availability and durability compared to LRS, as it protects against data center level failures. Both options ensure that your data is replicated 3 times, but they differ in how those copies are distributed. One LRS concentrates all copies in one location, offering lower latency but less protection against larger-scale events. 2. ZRS distributes copies across multiple zones, providing better protection against localized disasters at the cost of potentially slightly higher latency. The choice between LRS and ZRS depends on your specific needs for data availability, durability, and cost considerations. While LRS is the most cost-effective option, ZRS provides a better balance of cost and protection for many scenarios where high availability is crucial. Remember, this diagram represents redundancy only within the primary region. For protection against region-wide failures, you would need to consider geo-redundant options, which replicate data to a secondary region. Zone redundant storage, or ZRS, represents a significant leap forward in Azure's data redundancy options. This sophisticated storage solution is designed for availability zone-enabled regions, offering a robust approach to data protection and availability. At its core, ZRS operates by synchronously replicating your Azure storage data across 3 distinct Azure availability zones within the primary region. This approach provides an impressive level of durability, ensuring at least 12 nines, 99.9% of data object integrity over a given year. In practical terms, this means your data is exceptionally well protected against a wide range of potential issues. One of the key advantages of ZRS is its ability to maintain data accessibility even in challenging scenarios. If one of the availability zones becomes unavailable, your data remains accessible for both read and write operations. This high level of availability is crucial for applications that require constant uptime and data access. For users of Azure File Shares, ZRS offers an additional benefit. In the event of a zone becoming unavailable, no remounting of the file shares is required from the connected clients. This seamless continuity can significantly reduce downtime and maintain smooth operations for your applications and services. While ZRS provides robust protection and availability, it's important to understand how it operates during zone unavailability. When a zone becomes inaccessible, Azure takes proactive steps to ensure continued data access. This involves networking updates, including DNS repointing. However, it's crucial to note that these updates may temporarily impact your application if you attempt to access data before the updates are fully completed. Given its high availability and durability characteristics, Microsoft recommends using ZRS in the primary region for scenarios that require high availability. This makes ZRS an excellent choice for critical applications and services where downtime could have significant business impacts. Beyond its technical benefits, ZRS also offers advantages from a compliance and governance perspective. For organizations that need to restrict data replication within a specific country or region to meet data governance requirements, ZRS provides an effective solution. By keeping all data replications within the same region, ZRS helps maintain compliance with data localization regulations while still offering robust redundancy. In summary, zone redundant storage represents a powerful tool in Azure's storage portfolio. It offers a compelling balance of high durability, availability, and compliance features, making it an ideal choice for a wide range of enterprise storage needs. Whether you're running critical applications, dealing with sensitive data, or simply need the peace of mind that comes with top-tier data protection, ZRS is worth serious consideration in your Azure storage strategy. This diagram illustrates the concept of zone redundant storage, ZRS, in Azure, showcasing how data is replicated across multiple availability zones within a primary region. Key elements of the diagram. Primary region. The large rectangle encompassing the entire diagram represents the primary Azure region where ZRS is implemented. 2 availability zones. Within the primary region, we see 3 distinct rectangles, each representing an Azure availability zone. These zones are physically separate data centers within the same region, each with its own independent power, cooling, and networking infrastructure. 3 data copies. Inside each availability zone, there's a white rectangle representing a copy of the data. In ZRS, Your data is synchronously replicated across all 3 zones, ensuring that 3 identical copies exist at all times. For synchronous replication, the arrows connecting the data copies across zones represent synchronous replication. This means that any write operation is not considered complete until the data is safely stored in all 3 zones. 5. Client. At the bottom of the diagram, we see a client that can access the data. The dashed line from the client to the zones indicates that the client can read from or write to any of the zones. Key benefits illustrated by this diagram. High durability. With 3 copies of data spread across different physical locations, ZRS offers exceptional protection against data loss. High availability. If one zone becomes unavailable, the data remains accessible from the other 2 zones. Synchronous replication ensures data consistency across all zones. Transparent access. Clients can access data without needing to know which specific zone they're connecting to. This ZRS configuration provides a robust solution for applications that require high availability and durability within a single region, while also potentially meeting data residency requirements by keeping all data within the same geographic area. When it comes to ensuring the highest level of data durability, Azure Storage offers options that extend beyond a single region. For applications that demand exceptional resilience, you can opt to replicate your data to a secondary region located hundreds of miles away from the primary region. This approach provides a safeguard against catastrophic events that might render data in the primary region unrecoverable. Azure Storage presents 2 robust options for extending your data protection to a secondary region: Geo-Redundant Storage, GRS, and Geo-Zone Redundant Storage, GZRS. These options offer different levels of redundancy and protection. 1. Geo-Redundant Storage, GRS. This option is akin to running locally redundant storage, LRS, in 2 separate regions. It provides a straightforward approach to geographic redundancy. Geo-Zone Redundant Storage, GZRS. This more sophisticated option combines the benefits of Zone Redundant Storage, ZRS. In the primary region with LRS in the secondary region, it offers the highest level of availability and durability. When you set up your storage account, you have the flexibility to choose your primary region. However, it's important to note that the paired secondary region is predetermined based on Azure region pairs and cannot be altered. This pairing ensures optimal geographic separation while maintaining regional communication links for replication purposes. By default, data stored in the secondary region is not accessible for read or write operations. This design ensures data consistency and prevents unintended modifications to the backup data. However, in the event that the primary region becomes unavailable, Azure Storage provides a failover option. When initiated, this failover process transitions the secondary region into the role of the primary region, restoring full read and write access to your data. It's crucial to understand that data replication to the secondary region occurs asynchronously. This means that in the event of a failure affecting the primary region, there's a potential for data loss if the primary region cannot be recovered. The time gap between the most recent writes to the primary region and the last successful write to the secondary region is known as the Recovery Point Objective, RPO. For Azure Storage, the RPO is typically less than 15 minutes, although it's important to note that there's currently no Service Level Agreement, SLA, specifying the exact replication time to the secondary region. This asynchronous replication model offers a balance between performance and protection. It allows for efficient operations in the primary region, while still providing a high level of data durability. However, it's essential to consider this potential data gap in your disaster recovery planning, especially for applications where every transaction is critical. When implementing geo-redundant storage options, it's advisable to 1. Regularly test your failover process to ensure it works as expected. Consider the RPO in your application design, especially for data-critical operations. 3. Use Azure storage metrics and logging to monitor replication status and lag. 4. Educate your team about the failover process and its implications on data consistency. By leveraging these secondary region redundancy options and understanding their characteristics, you can significantly enhance your data's resilience against large-scale disasters, ensuring business continuity even in the most challenging circumstances. Geo-redundant storage, or GRS, represents a powerful strategy in Azure's data redundancy arsenal, designed to provide exceptional durability and protection against large-scale disasters. Let's break down how GRS works and what it offers. Primary region replication. In the primary region, GRS leverages locally redundant storage, LRS, to create 3 synchronous copies of your data. These copies are distributed within a single physical location, providing protection against hardware failures and local network issues. Secondary region. Replication GRS then takes an extra step by asynchronously copying your data to a secondary region. This secondary region is predetermined based on Azure's region pairs, typically hundreds of miles away from the primary region. In the secondary region, the data is again stored using LRS, creating 3 more copies. Asynchronous replication. It's important to note that the replication to the secondary region is asynchronous. This means there could be a slight delay between updates in the primary region and their reflection in the secondary region. While this delay is typically minimal, it's a factor to consider in your disaster recovery planning. Exceptional durability. The combination of local and geo-replication results in outstanding durability. GRS offers durability for Azure storage data objects of at least 16 nines, 99.9% over a given year. This level of durability is suitable for the most critical data and applications. Protection against region-wide outages. By replicating data to a geographically distant region, GRS provides a safeguard against large-scale disasters that might affect an entire region. This could include natural disasters, widespread power outages, or other catastrophic events. Failover capabilities. In the event of a major outage in the primary region, Azure provides the option to fail over to the secondary region. This process transitions the secondary region to become the new primary, allowing continued access to your data. Cost considerations. While GRS offers superior protection, it does come at a higher cost compared to locally redundant options. Organizations need to balance their durability and availability requirements with budget constraints. Use cases. GRS is ideal for applications that require high durability and availability, especially those that are critical to business operations. It's particularly suited for scenarios where data loss could have severe financial or operational consequences. By implementing GRS, organizations can ensure that their data remains protected and accessible, even in the face of significant regional disruptions. This level of protection provides peace of mind for businesses handling mission-critical data and applications, allowing them to maintain operations and meet stringent compliance requirements. This diagram illustrates the concept of geo-redundant storage, GRS, in Azure, showcasing how data is replicated both within a primary region and to a secondary region. Key elements of the diagram. Primary region. The large rectangle on the left represents the primary Azure region, where your data is initially stored and processed. Primary data center. Within the primary region, we see a data center where the data is stored using locally redundant storage, LRS. Primary region data copies. Inside the primary data center, there are 3 copies of the data. These copies are created synchronously, ensuring immediate consistency across all 3. Synchronous replication. Arrows. The solid arrows between the data copies in the primary region represent synchronous replication, indicating that all copies are updated simultaneously. Secondary region. The large rectangle on the right represents the secondary Azure region, typically hundreds of miles away from the primary region. Secondary data center. Similar to the primary region, the secondary region contains a data center where replicated data is stored. Secondary region. Data copies. The secondary region also maintains 3 copies of the data, again using LRS. Asynchronous replication. Arrow. The dashed arrow between the primary and secondary regions represents asynchronous replication. This indicates that there may be a slight delay between updates in the primary region and their reflection in the secondary region. Client. At the bottom of the diagram, we see a client that can access the data. The solid line from the client to the primary region indicates that under normal circumstances, read and write operations occur in the primary region. Key benefits illustrated by this diagram. High durability. With 6 total copies of data, 3 in each region, GRS offers exceptional protection against data loss. Disaster recovery. By replicating data to a geographically distant region, GRS provides a safeguard against regional disasters. Synchronous local replication ensures high consistency and availability within the primary region. Asynchronous geo-replication offers protection against regional outages without impacting the performance of primary region operations. This GRS configuration provides a robust solution for applications that require both high availability within a region and protection against large-scale geographic disasters. It's particularly suitable for critical business applications, where data loss or extended downtime could have severe consequences. GeoZone Redundant Storage, GZRS, represents the pinnacle of Azure's data redundancy options, offering a comprehensive solution that addresses both local high availability and protection against large-scale regional outages. Let's delve into the key aspects of GZRS primary region redundancy. In the primary region, GZRS leverages Zone Redundant Storage, ZRS, to replicate your data synchronously across 3 Azure availability zones. Each availability zone is a separate physical location with independent power, cooling, and networking infrastructure. This approach provides robust protection against local failures and maintains high availability within the primary region. Secondary region. Replication, GZRS, takes data protection a step further by asynchronously replicating your data to a secondary geographic region. In this secondary region, the data is stored using locally redundant storage, LRS, creating 3 additional copies in a single facility. The secondary region is typically hundreds of miles away from the primary region, offering protection against large-scale disasters that might affect an entire region. Comprehensive disaster recovery. By combining zone-redundant storage in the primary region with geo-replication to a secondary region, GZRS offers a comprehensive disaster recovery solution. It protects against both localized failures, such as hardware issues or power outages in a single zone, and region-wide disasters, like natural calamities affecting an entire geographic area. High performance. Despite the multiple layers of redundancy, GZRS is designed to maintain excellent performance. The use of ZRS in the primary region ensures low latency access to data, while the asynchronous replication to the secondary region doesn't impact the performance of primary region operations. Maximum consistency and durability. GZRS offers the highest level of data consistency and durability among Azure storage options. The combination of synchronous local replication across zones and asynchronous geo-replication provides an exceptionally robust safeguard against data loss. Ideal for critical applications, Microsoft recommends GZRS for applications that require maximum consistency, durability, and availability. It's particularly well suited for mission-critical workloads, where any data loss or downtime could have severe consequences. Failover capabilities. In the event of a catastrophic failure in the primary region, GZRS allows for failover to the secondary region. This process can be initiated manually or set up for automatic failover, ensuring continuous access to your data even in extreme scenarios. Compliance and data governance. For organizations with strict compliance requirements or data governance policies, GZRS offers the ability to maintain copies of data in geographically distinct locations while still providing the option to restrict access to the secondary region under normal conditions. This diagram illustrates the concept of GeoZone Redundant Storage, GZRS, in Azure, showcasing how data is replicated both across availability zones within a primary region and to a secondary region. Key elements of the diagram. Primary region. The large rectangle on the left represents the primary Azure region, where your data is initially stored and processed. Availability zones. Within the primary region, we see three distinct rectangles, each representing an Azure availability zone. These zones are physically separate data centers within the same region, each with its own independent power, cooling, and networking infrastructure. Primary region data copies. Inside each availability zone, there's a copy of the data. This represents the Zone Redundant Storage, ZRS aspect of GZRS, where data is synchronously replicated across three zones. Synchronous replication arrows. The solid arrows between the data copies in the primary region represent synchronous replication, indicating that all copies are updated simultaneously across the three zones. Secondary region. The large rectangle on the right represents the secondary Azure region, typically hundreds of miles away from the primary region. Secondary data center. Within the secondary region, we see a single data center where replicated data is stored using locally redundant storage, LRS. Secondary region data copies. The secondary region maintains three copies of the data within the single data center, representing the LRS aspect in the secondary region. Asynchronous replication arrow. The dashed arrow between the primary and secondary regions represents asynchronous replication. This indicates that there may be a slight delay between updates in the primary region and their reflection in the secondary region. Client. At the bottom of the diagram, we see a client that can access the data. The solid line from the client to the primary region indicates that under normal circumstances, read and write operations occur in the primary region. Key benefits illustrated by this diagram. High availability. By replicating data across three availability zones in the primary region, GZRS provides excellent protection against localized failures and maintains high availability. Disaster recovery. The asynchronous replication to a geographically distant secondary region offers protection against large-scale regional disasters. Comprehensive protection. GZRS combines the benefits of ZRS, protection against zone-level failures, and GRS, protection against region-wide outages. Performance. The use of ZRS in the primary region ensures low latency access to data for regular operations. Durability. With multiple copies spread across zones and regions, GZRS offers exceptionally high durability for stored data. This GZRS configuration provides the most robust solution for applications that require maximum consistency, durability, and availability. It's particularly suitable for mission-critical. Azure's geo-redundant storage options, GRS and GZRS, provide robust protection against regional outages by replicating data to a secondary region. However, in their standard configuration, this replicated data is not accessible unless a failover is initiated. To address this limitation and enhance data availability, Azure offers Read Access Geo-Redundant Storage, RAGRS, and Read Access GeoZone Redundant Storage, RAGZRS. Let's explore these options in detail. 1. RAGRS, Read Access Geo-Redundant Storage. Built on top of GRS, RAGRS allows read access to data in the secondary region without the need for failover. Provides higher availability for your data, as it can be read from the secondary region even if the primary region is fully operational. Ideal for scenarios where you need to distribute read workloads geographically or require immediate read access to data in case of primary region issues. RAGZRS, Read Access GeoZone Redundant Storage. An extension of GZRS, RAGZRS, combines the high availability of zone redundant storage in the primary region with read access to the secondary region, offers the highest level of availability among Azure storage options, providing resilience against both zone-level and regional failures, along with constant read access to the secondary region, suitable for mission-critical workloads that require both maximum durability and continuous data access. Key benefits: always available. Data in the secondary region is always accessible for read operations, even when the primary region is running optimally. No failover required. You can read data from the secondary region without initiating a failover process, reducing complexity and potential downtime. Improved performance. Allows for geographic distribution of read workloads, potentially improving performance for users in different regions. Enhanced business continuity. Provides immediate read access to data in case of issues with the primary region, supporting robust disaster recovery strategies. Important considerations: Recovery Point Objective, RPO. It's crucial to remember that due to the asynchronous nature of geo-replication, the data in the secondary region may not be fully up to date. The time lag between the last update in the primary region and its reflection in the secondary region is known as the RPO. This lag is typically less than 15 minutes but can vary. Read-only access. The secondary region provides read-only access. All write operations must still be directed to the primary region. Consistency. When reading from the secondary region, you may encounter eventually consistent data. Always consider this when designing applications that utilize RAGRS or RAGZRS. Cost. Enabling read access to the secondary region comes with additional costs compared to standard GRS or GZRS. Application design. To fully leverage RAGRS or RAGZRS, applications need to be designed to utilize the secondary endpoint. Azure Storage serves as the foundation for data management in the cloud. It offers a comprehensive suite of services designed to meet diverse storage needs. Let's explore the key components of the Azure Storage Platform. At the heart of Azure Storage lies Azure Blobs, a robust object store capable of handling massive amounts of unstructured data. Whether you're dealing with text files or binary data, Azure Blobs provides the scalability and flexibility to accommodate your needs. For organizations working with big data, Azure Blobs also incorporates Data Lake Storage Gen 2, enabling advanced analytics capabilities. Moving on to file storage, Azure Files presents a fully managed file share solution. This service proves invaluable for both cloud-native applications and hybrid scenarios, where on-premises systems need to interact with cloud storage. Azure Files simplifies data management and access across diverse environments. For applications requiring asynchronous communication, Azure Queues offers a reliable messaging store. This service facilitates seamless interaction between different components of your application, ensuring smooth data flow and processing. When it comes to virtual machine storage, Azure Disks provides block-level storage volumes. These volumes integrate seamlessly with Azure VMs, offering the performance and reliability needed for mission-critical workloads. Lastly, Azure Tables presents a NoSQL database option for structured non-relational data. This service is ideal for scenarios where you need to store large amounts of structured data that doesn't require complex joins, foreign keys, or stored procedures. Each of these services plays a crucial role in the Azure storage ecosystem, providing developers and IT professionals with a comprehensive toolkit to address various data storage challenges. Azure Storage offers a multitude of advantages that make it an attractive solution for businesses of all sizes. Let's delve into these benefits to understand why Azure Storage stands out in the cloud computing landscape. First and foremost, Azure Storage prides itself on being durable and highly available. Through intelligent redundancy mechanisms, your data remains safe even in the face of hardware failures. For those seeking an extra layer of protection, Azure allows you to replicate data across multiple data centers or geographical regions. This feature ensures that your data stays accessible even in the unlikely event of a large-scale disaster. Security stands as another cornerstone of Azure Storage. By default, all data written to an Azure Storage account undergoes encryption, safeguarding your information from unauthorized access. Moreover, Azure Storage provides granular control over data access, allowing you to implement robust security policies tailored to your organization's needs. Scalability is a key strength of Azure Storage, designed to meet the ever-growing data demands of modern applications. Whether you're dealing with terabytes or petabytes of data, Azure Storage can effortlessly scale to accommodate your needs without compromising performance. The managed nature of Azure Storage alleviates the burden of infrastructure maintenance from your IT team. Microsoft takes care of hardware maintenance, updates, and critical issues, allowing your team to focus on developing and improving your applications rather than managing storage infrastructure. Lastly, Azure Storage shines in its accessibility. Your data remains accessible from anywhere in the world via HTTP or HTTPS protocols. Microsoft provides a wide array of client libraries for Azure Storage, supporting popular programming languages like .NET, Java, Node.js, Python, and many others. Additionally, Azure Storage integrates seamlessly with Azure PowerShell and Azure CLI for easy scripting and automation. Azure Blob Storage stands at the forefront of cloud-based object storage solutions. This powerful service is designed to handle vast amounts of unstructured data, ranging from simple text files to complex binary data. The beauty of Azure Blob Storage lies in its flexibility. There are no restrictions on the types of data it can accommodate. One of the key strengths of Azure Blob Storage is its ability to manage concurrent operations at scale. It can effortlessly handle thousands of simultaneous uploads, making it ideal for high-traffic applications. Whether you're dealing with massive video files, ever-growing log files, or any other data-intensive scenario, Azure Blob Storage rises to the challenge. Accessibility is another crucial feature of Azure Blob Storage. Your data can be accessed from anywhere in the world, provided there's an internet connection. This global reach makes it an excellent choice for distributed applications and teams working across different geographical locations. When it comes to data formats, Azure Blob Storage doesn't impose any limitations. It can store gigabytes of binary data streamed from scientific instruments, encrypted messages for secure applications, or data in custom formats for specialized apps. This versatility allows developers to focus on their application logic rather than worrying about data storage intricacies. One significant advantage of blob storage over traditional disk storage is its abstraction of physical storage management. Developers can upload data as blobs without concerning themselves with the underlying disk structure. Azure takes care of all the physical storage needs, significantly simplifying the development process and reducing the overhead of storage management. Azure Blob Storage proves invaluable in a wide range of scenarios. Let's explore some of its ideal use cases. Firstly, it excels at serving images or documents directly to a browser. This capability makes it perfect for content delivery networks, e-commerce platforms, or any application that needs to efficiently serve static content to users. Secondly, Azure Blob Storage is excellent for storing files for distributed access. This feature is particularly useful for organizations with geographically dispersed teams. that need to collaborate on shared files. In the realm of multimedia, Azure Blob Storage shines in streaming video and audio content. Its ability to handle large files and provide smooth streaming makes it an ideal choice for media-heavy applications, from video-on-demand services to online learning platforms. Data protection is another area where Azure Blob Storage proves its worth. It serves as a robust solution for storing data for backup and restore operations, disaster recovery, and long-term archiving. This capability ensures that your critical data remains safe and accessible, even in the face of unexpected events. Lastly, Azure Blob Storage plays a crucial role in data analytics. Whether you're using on-premises services or Azure-hosted solutions, Blob Storage can efficiently store and provide access to large data sets for analysis. This feature is particularly valuable in big data scenarios, where the ability to store and process massive amounts of data is paramount. Azure Blob Storage offers unparalleled accessibility, allowing users to reach their data from any corner of the globe via standard HTTP or HTTPS protocols. This universal access is a key feature that sets Azure Blob Storage apart in the cloud storage landscape. One of the most straightforward ways to access blobs is through URLs. These web addresses provide a direct link to your stored objects, making it easy to integrate blob data into web applications or share files with others. For developers seeking more programmatic control, the Azure Storage REST API presents a powerful interface. This API allows for fine-grained management of blob storage, enabling operations like creating containers, uploading blobs, and setting access policies. Azure PowerShell and Azure CLI cater to IT professionals and developers who prefer command-line interfaces. These tools provide a set of templates and commands that make it easy to manage blob storage directly from the command line, facilitating automation and scripting of storage operations. Perhaps the most versatile method of accessing blob storage is through the Azure Storage Client libraries. Microsoft provides these libraries for a wide array of programming languages, including .NET, Java, Node.js, Python, PHP, and Ruby. This broad language support ensures that developers can work with blob storage using their preferred programming language, seamlessly integrating Azure storage capabilities into their applications. In the ever-evolving landscape of cloud storage, managing costs while meeting diverse data access needs is a critical challenge. Azure Blob Storage addresses this challenge head-on with its tiered storage system, offering a nuanced approach to data management that aligns with the life cycle of your data. The exponential growth of data in cloud environments necessitates a strategic approach to storage. Not all data is created equal. Some data sets require frequent access throughout their lifetime, while others may see their access patterns change dramatically over time. Some data might remain dormant for extended periods, accessed only in rare circumstances. Recognizing these varied needs, Azure provides several access tiers for blob storage. These tiers allow you to optimize your storage costs based on your specific access patterns and retention requirements. Let's explore each of these tiers in detail. The Hot Access tier is designed for data that sees frequent access. This tier is ideal for scenarios where data is actively used and modified regularly. For instance, if you're running a content-heavy website, the images and other media files that are constantly being served to users would be perfect candidates for the Hot tier. The Cool Access tier is optimized for data that is accessed less frequently, but still requires quick access when needed. This tier is most cost-effective for data that will be stored for at least 30 days. A common use case for the Cool tier might be storing customer invoices. They're not accessed daily, but when they are needed, you want them readily available. The Cold Access tier is designed for even less frequently accessed data, with a minimum storage duration of 90 days. This tier strikes a balance between lower storage costs and reasonable access times, making it suitable for short-term backups or older data that still needs to be readily accessible. The Archive Access tier is the most cost-effective option for data that is rarely accessed and can tolerate higher latencies in retrieval. With a minimum storage duration of 180 days, this tier is perfect for long-term backups, historical data, or compliance archives. When considering these storage tiers, it's important to understand their key characteristics and how they can be applied. The hot, cool, and cold tiers can be set at the account level, providing a default tier for all blobs in the account. This feature is particularly useful when you have a storage account dedicated to a specific type of data with consistent access patterns. All 4 tiers, hot, cool, cold, and archive, can be set at the individual blob level. This granular control allows you to optimize storage costs on a per-object basis. You can set the tier during upload or change it at any time during the blob's lifecycle, providing flexibility as your data access patterns evolve. While the cool and cold tiers offer cost savings, they come with some trade-offs. These tiers may have slightly lower availability compared to the hot tier. However, they still maintain high durability and similar retrieval latency and throughput characteristics. The lower availability is offset by reduced storage costs, making these tiers attractive for data that doesn't require the highest level of availability. The archive tier stands apart in terms of data access. When you move data to the archive tier, it's taken offline, significantly reducing storage costs. However, retrieving data from the archive tier involves a rehydration process, which can take several hours and incurs higher access costs. This trade-off makes the archive tier ideal for data that needs to be retained for long periods, but is rarely, if ever, accessed. Azure Files represents a significant leap forward in cloud-based file storage solutions, offering fully managed file shares that seamlessly bridge the gap between on-premises and cloud environments. This service stands out for its ability to provide shared access using industry-standard protocols, making it an ideal choice for organizations looking to modernize their file storage infrastructure without disrupting existing workflows. At its core, Azure Files supports 2 key protocols: the Server Message Block, SMB, and the Network File System, NFS. This dual protocol support ensures broad compatibility across different operating systems and use cases. SMB, a protocol widely used in Windows environments, allows Azure file shares to be easily integrated with Windows, Linux, and Mac OS systems. On the other hand, NFS support caters specifically to Linux and Mac OS clients, providing a native file sharing experience for these platforms. One of the standout features of Azure Files is its ability to support concurrent mounting of file shares. This means that whether your applications are running in the cloud or on premises, they can simultaneously access the same file shares. This capability is particularly valuable in hybrid cloud scenarios, where organizations need to maintain seamless data access across diverse environments. For Windows environments, Azure Files offers an additional layer of functionality through Azure File Sync. This feature allows you to cache Azure file shares on Windows servers, bringing the data closer to where it's being used. This approach significantly enhances performance for frequently accessed files, while maintaining the benefits of centralized cloud storage. The fully managed nature of Azure Files is a game changer for IT operations. By eliminating the need to manage hardware or operating systems, Azure Files frees up valuable IT resources. You no longer need to worry about routine, but critical tasks such as patching server operating systems or replacing faulty hard drives. This shift allows IT teams to focus on more strategic initiatives rather than day-to-day storage management. Azure Files shines in its support for scripting and tooling, offering robust integration with popular management tools. PowerShell CMDlets and Azure CLI provide powerful command-line interfaces for creating, mounting, and managing Azure file shares. This scriptability is invaluable for automating storage management tasks and integrating file share operations into broader application deployment and management workflows. For those who prefer graphical interfaces, Azure Files is fully supported in the Azure Portal and Azure Storage Explorer. These tools provide intuitive, user-friendly interfaces for managing your file shares, making it easy for administrators of all skill levels to work with Azure Files. Resiliency is a cornerstone of Azure Files' design philosophy. Built from the ground up with high availability in mind, Azure Files eliminates many of the concerns associated with traditional on-premises file storage. By migrating to Azure Files, organizations can say goodbye to middle-of-the-night emergencies caused by local power outages or network issues. This built-in resiliency ensures that your data remains accessible and protected, even in the face of infrastructure challenges. From a development perspective, Azure Files offers familiar programmability that eases the transition to cloud-based storage. Applications running in Azure can interact with file shares using standard file system I/O APIs. This compatibility means that developers can leverage their existing code and skills when working with Azure Files, significantly reducing the learning curve and accelerating cloud adoption. For more advanced scenarios or when working with other programming languages, Azure Files is fully supported by the Azure Storage Client libraries. These libraries provide language-specific APIs for interacting with Azure Files, offering a consistent and idiomatic experience across different programming environments. Additionally, for the utmost in flexibility, the Azure Storage REST API is available, allowing direct HTTP-based access to Azure Files resources. Azure Queue Storage emerges as a powerful solution for managing large volumes of messages in the cloud. This service plays a crucial role in building scalable and decoupled applications, particularly those that require asynchronous processing or need to handle spikes in workload efficiently. At its core, Azure Queue Storage is designed to store vast numbers of messages. The capacity of a queue is limited only by the total size of your storage account, potentially allowing for millions of messages to be stored. This scalability makes queue storage an ideal choice for applications that need to handle high message volumes or experience fluctuating workloads. One of the key strengths of Azure Queue Storage is its accessibility. Messages stored in a queue can be accessed from anywhere in the world via authenticated HTTP or HTTPS calls. This global accessibility ensures that your application components can interact with the queue regardless of their geographical location, facilitating the development of distributed systems. Each message in Azure Queue Storage can be up to 64 KB in size. While this might seem limiting for larger payloads, it's important to note that queues are typically used for short, action-oriented messages rather than for storing large amounts of data. For scenarios requiring larger message sizes, a common pattern is to store the bulk of the data in another Azure storage service, like blob storage, and use the queue message to store a reference to this data. A common use case for Azure Queue Storage is creating a backlog of work to be processed asynchronously. This pattern is particularly useful in scenarios where you need to defer processing to a later time or distribute work across multiple worker processes. For example, in a web application, you might use a queue to handle time-consuming tasks that don't need to be completed during the user's request-response cycle, improving the responsiveness of your application. The true power of Azure Queue Storage becomes evident when combined with compute services like Azure Functions. This integration allows you to create event-driven, serverless architectures that can automatically scale based on the queue load. Here's a practical example to illustrate this. Imagine you have a website where customers can upload forms. Instead of processing these forms synchronously, which could lead to slow response times during peak periods, you could design the system as follows. When a customer uploads a form, the website doesn't process it immediately. Instead, it places a message in an Azure queue containing either the form data or a reference to where the form is stored. You then set up an Azure function that is triggered whenever a new message appears in the queue. This Azure function processes the form data asynchronously, perhaps storing it in a database, sending confirmation emails, or performing any other required actions. This approach offers several benefits. The website remains responsive, as it's not burdened with processing the forms. Processing can be scaled independently of the website. During busy periods, multiple instances of the Azure function can run in parallel to handle the increased load. If the processing system experiences issues, the messages remain safely in the queue until they can be processed, ensuring no data is lost. By leveraging Azure Queue Storage in this way, you can build more resilient, scalable, and efficient applications. The queuing mechanism allows you to smooth out peaks in workload, decouple different parts of your application, and ensure that work is processed in a reliable and scalable manner. In essence, Azure Queue Storage serves as a crucial building block for creating distributed and loosely coupled systems in the cloud. Whether you're building a small application or a large-scale enterprise solution, understanding and utilizing Azure Queue Storage can significantly enhance your ability to create robust, scalable, and efficient cloud-native applications. Azure Disk Storage, also known as Azure Managed Disks, represents a significant leap forward in cloud-based storage solutions for virtual machines. These block-level storage volumes are fully managed by Azure, offering a seamless and efficient storage experience for Azure VMs. Conceptually, Azure Managed Disks are analogous to physical disks in a traditional server, but they bring the added benefits of virtualization. This virtual nature allows for enhanced resiliency and availability compared to physical disks. In the event of hardware failures or other infrastructure issues, Azure can quickly migrate your disk to healthy hardware, ensuring continued availability of your data and applications. One of the key advantages of Azure Managed Disks is their simplicity from a user perspective. As an Azure user, your primary responsibility is to provision the disk, specifying its size and performance characteristics. Once you've done this, Azure takes care of the rest. This includes managing the underlying storage infrastructure, ensuring data redundancy, and handling any necessary maintenance or upgrades. This managed approach brings several benefits. Simplified management. You don't need to worry about the complexities of storage account management. Azure handles the storage backend, allowing you to focus on your applications and workloads. Improved reliability. Azure automatically stores 3 replicas of your data, providing built-in protection against hardware failures and enhancing data durability. Seamless scalability. You can easily increase the size of a managed disk without having to worry about the underlying storage account limits. Enhanced security. Azure Disk Encryption can be used with managed disks to secure your data at rest. Granular access control. Azure Role-Based Access Control, RBAC, can be applied directly to managed disks, allowing for fine-grained control over who can access and manage your disks. Azure Managed Disks come in various types to suit different performance and cost requirements. These include ultra-disk storage for extremely high-performance workloads, premium SSD for production, and performance-sensitive workloads. Standard SSD for workloads that need consistent performance, and standard HDD for backup and non-critical workloads. By leveraging Azure Managed Disks, organizations can significantly simplify their storage management tasks while benefiting from the scalability, reliability, and performance of cloud-based storage. Whether you're running a small application or managing a large-scale enterprise deployment, Azure Managed Disks provide a robust and flexible storage solution for your Azure virtual machines. Azure Table Storage stands out as a versatile and powerful solution for storing large amounts of structured data in the cloud. As a NoSQL data store, it offers a unique blend of simplicity, scalability, and flexibility that makes it an attractive option for a wide range of applications and use cases. One of the key strengths of Azure Tables is its ability to handle massive amounts of structured data. Unlike traditional relational databases, Azure Tables uses a schema-less design. This means you can adapt your data model on the fly, without the need for complex migrations or downtime. Each entity, or row, in an Azure table can have a different structure, allowing for great flexibility in how you store and organize your data. Azure Tables are designed with accessibility in mind. They accept authenticated calls from both inside and outside the Azure cloud environment. This feature opens up a world of possibilities for building hybrid or multi-cloud solutions. You can have applications running on-premises, in Azure, or even in other cloud platforms, all seamlessly interacting with the same Azure table storage. This global accessibility ensures that your data is always available where you need it. Whether you're building a globally distributed application or need to maintain data consistency across different environments, Azure Tables provide the flexibility and reach to meet these requirements. Azure Tables are particularly well suited for storing structured, non-relational data. This makes them ideal for scenarios such as storing user data for web applications, maintaining address books or contact information, storing device or sensor information for IoT applications, managing product catalogs, storing any kind of metadata for your applications. The simplicity of the Azure Table storage model also translates into cost-effectiveness. With Azure Tables, you only pay for the storage you use and the operations you perform, making it an economical choice for storing large volumes of data. When it comes to querying data, Azure Tables support simple lookup and filter operations. While they may not offer the complex join operations of relational databases, they excel in scenarios where you need fast, scalable access to structured data based on a partition key and a row key. Azure Tables also integrate well with other Azure services. For instance, you can use Azure Functions to trigger actions based on changes in your table data, or use Azure Logic Apps to incorporate table storage operations into your business processes. In essence, Azure Table Storage provides a robust, scalable, and flexible solution for storing structured data in the cloud. Its ability to handle large volumes of data, coupled with its accessibility from various environments, makes it a valuable tool in any cloud developer's toolkit. Whether you're building a small application or a large-scale distributed system, Azure Tables offer a straightforward yet powerful way to manage your data. Azure Migrate stands at the forefront of cloud migration solutions, offering a comprehensive platform for transitioning your on-premises environment to Azure. This powerful service acts as a centralized hub, streamlining the entire migration process from initial assessment to final implementation. At its core, Azure Migrate provides a unified migration platform. This means you have access to a single portal where you can initiate, execute, and monitor your migration journey to Azure. This centralized approach significantly reduces complexity and improves overall efficiency in your migration efforts. One of Azure Migrate's key strengths lies in its diverse range of tools for assessment and migration. These tools are designed to cater to various aspects of the migration process, ensuring that you have the right resources at your disposal for each step of your journey. From discovering your current infrastructure to planning your migration strategy, these tools provide invaluable support throughout the process. Furthermore, Azure Migrate doesn't operate in isolation. It seamlessly integrates with other Azure services and tools, creating a robust ecosystem for your migration needs. This integration extends beyond Microsoft's offerings, as Azure Migrate also works harmoniously with independent software vendor ISV solutions. This flexibility allows you to leverage your preferred tools and services, making the migration process more aligned with your organization's specific requirements and preferences. Azure Migrate offers a comprehensive suite of integrated tools, each designed to address specific aspects of the migration process. Let's explore these tools and their functionalities. First, we have Azure Migrate, Discovery and Assessment. This tool is your starting point, enabling you to discover and assess on-premises servers running on various platforms such as VMware, Hyper-V, and physical servers. It provides crucial insights to prepare for your migration to Azure. Next is Azure Migrate, Server Migration. This tool takes the next step, facilitating the actual migration of VMware VMs, Hyper-V VMs, physical servers, other virtualized servers, and even public cloud VMs to Azure. It streamlines the process of moving your server infrastructure to the cloud. For database migration, Azure offers two specialized tools. The Data Migration Assistant is a standalone tool focused on assessing SQL servers. It helps identify potential migration blockers, highlights unsupported features, and suggests new features that could benefit you post-migration. Working in tandem with this is the Azure Database Migration Service, which handles the actual migration of on-premises databases to Azure VMs running SQL Server, Azure SQL Database, or SQL Managed Instances. Web application migration is addressed by the Azure App Service Migration Assistant. This standalone tool is designed to assess on-premises websites and facilitate their migration to Azure App Service. It's particularly useful for migrating .NET and PHP web apps to Azure. Lastly, for scenarios involving large amounts of offline data, Azure provides the Azure Data Box. This tool is designed to securely and efficiently move substantial volumes of data to Azure when network transfer is not feasible or cost-effective. Azure Data Box emerges as a game-changer in the realm of large-scale data migration. This physical migration service addresses the challenges of transferring massive volumes of data to the cloud, offering a solution that is not only quick and reliable, but also cost-effective. At the heart of the Azure Data Box service is a proprietary storage device, purpose-built for secure data transfer. This robust device boasts an impressive 80 terabytes of usable storage capacity, making it suitable for even the most data-intensive migration scenarios. Microsoft has prioritized the security and durability of the data box, housing it in a rugged case that shields it from potential damage during transit. The versatility of Azure Data Box is evident in its support for both import and export scenarios. Whether you're looking to move large data sets into Azure or extract substantial amounts of data from the cloud, DataBox has you covered. This flexibility makes it an invaluable tool for various use cases, from initial bulk data transfers to periodic large-scale data exchanges between on-premises environments and Azure. The process of using Azure Data Box is straightforward and user-friendly. It begins in the Azure portal, where you can place an order for the device. Once the data box arrives at your data center, setting it up is a breeze thanks to its local web UI. You can swiftly connect it to your network and commence the data transfer process. After you've completed transferring your data, simply return the data box to Microsoft. If you're importing data to Azure, you'll be pleased to know that the data is automatically uploaded to your specified Azure storage account upon receipt of the device. This automation minimizes manual intervention and accelerates the availability of your data in the cloud. A standout feature of the Azure Data Box service is its comprehensive tracking capability. The entire process, from ordering the device to the final data upload, is meticulously tracked end-to-end within the Azure portal. This visibility ensures you're always informed about the status of your data migration, providing peace of mind throughout the process. By offering this physical data transfer option, Azure Data Box effectively addresses the challenges associated with migrating large volumes of data over networks with limited bandwidth or high costs. It provides a pragmatic solution for scenarios where traditional network-based transfers would be impractical or prohibitively expensive. thereby expanding the accessibility of Azure's powerful cloud services to a broader range of organizations and use cases. Azure DataBox proves its versatility through a wide array of use cases, catering to diverse data migration needs. This robust solution is particularly effective for transferring data volumes exceeding 40 terabytes, especially in environments with limited or no network connectivity. Let's explore the various scenarios where DataBox shines, both for importing data to Azure and exporting data from Azure. Import scenarios showcase the power of DataBox in bringing large volumes of on-premises data into the Azure cloud. One common use case is one-time migration, where organizations move substantial amounts of data to Azure as part of a cloud adoption strategy. This could involve transferring entire databases, file shares, or application data. Media companies find DataBox invaluable for moving offline media libraries into Azure. By transferring content from physical tapes to Azure storage, they can create accessible online media libraries, enabling easier content management and distribution. In the realm of infrastructure migration, DataBox facilitates the move of entire VM farms, SQL servers, and applications to Azure. This use case is particularly relevant for organizations undergoing large-scale cloud migrations or data center consolidations. For businesses looking to leverage Azure's advanced analytics capabilities, DataBox offers a way to move historical data to Azure. This data can then be analyzed using services like Azure AD Insight, unlocking valuable insights from legacy data. DataBox also supports hybrid scenarios. It can be used for initial bulk transfers, also known as seeding, followed by incremental updates over the network. This approach is ideal for organizations that need to migrate large datasets quickly, but can handle smaller, ongoing updates via their network connection. Periodic uploads represent another key use case. Some industries generate large volumes of data at regular intervals, such as scientific research facilities or media production houses. DataBox provides an efficient means to move this data to Azure for processing, storage, or archiving. Turning to export scenarios, DataBox proves equally valuable. In disaster recovery situations, it enables rapid restoration of large volumes of Azure data to on-premises infrastructure. This capability ensures business continuity even in the face of major disruptions. For organizations operating under strict security or regulatory requirements, DataBox offers a secure method to export data from Azure. This use case is particularly relevant in industries with data sovereignty concerns or specific compliance needs. Lastly, DataBox supports scenarios where data needs to be migrated back to on-premises infrastructure or to another cloud service provider. This flexibility ensures that organizations are not locked into a single cloud ecosystem and can move their workloads as business needs evolve. It's worth noting the strong emphasis on data security throughout the DataBox. While Azure offers robust solutions for large-scale data migration, it also provides versatile tools for managing individual files or small file groups. These tools cater to different needs and preferences, offering both command line and graphical interfaces, as well as advanced synchronization capabilities. Let's explore three key options: AsCopy, Azure Storage Explorer, and Azure File Sync. AsCopy stands out as a powerful command line utility designed for efficient file operations. It excels in copying blobs or files to and from your Azure storage account. With AsCopy, you can perform a variety of tasks such as uploading files, downloading files, and copying files between storage accounts. One of its notable features is the ability to synchronize files, although it's important to note that this synchronization is unidirectional. When you use AsCopy for synchronization, you specify a source and a destination, and the tool copies files or blobs in that direction only. It doesn't perform bidirectional synchronization based on timestamps or other metadata. Interestingly, AsCopy can be configured to work with other cloud providers, facilitating file movement between different cloud environments. For those who prefer a more visual approach to file management, Azure Storage Explorer offers a user-friendly graphical interface. This standalone application allows you to manage files and blobs in your Azure Storage account through an intuitive UI. One of its key advantages is its cross-platform compatibility, supporting Windows, Mac OS, and Linux operating systems. Under the hood, Storage Explorer leverages AzCopy to perform file and blob management tasks, combining the power of AzCopy with the convenience of a graphical interface. With Storage Explorer, you can easily upload files to Azure, download files from Azure, or move files between different storage accounts. Azure File Sync takes file management to the next level by enabling you to centralize your file shares in Azure Files, while maintaining the flexibility, performance, and compatibility of a Windows file server. It's akin to transforming your Windows file server into a miniature content delivery network. Once installed on your local Windows server, Azure File Sync ensures automatic bidirectional synchronization with your files in Azure. This tool offers several compelling features. Protocol flexibility. You can use any protocol available on Windows Server to access your data locally, including SMB, NFS, and FTPS. Global caching. Azure File Sync allows you to have as many caches as needed across the world, improving file access performance for geographically distributed teams. Quick recovery. In case of a local server failure, you can quickly recover by installing Azure File Sync on a new server in the same data center. Intelligent Cloud. Tiering. This feature allows you to configure cloud tiering so that frequently accessed files are replicated locally, while infrequently accessed files are kept in the cloud until requested. This optimizes storage usage and can significantly reduce on-premises storage costs. Let's have a quick look at knowledge check questions, along with correct answers and explanations. Which tool automatically keeps files between an on-premises Windows server and an Azure cloud environment updated? Correct answer: A. Azure File Sync. Explanation. Azure File Sync is designed to synchronize files between on-premises Windows servers and Azure cloud storage. It provides bidirectional synchronization, ensuring that files are automatically updated in both environments. Azure Storage Explorer is a management tool, and AzCopy is a command-line utility for file transfer, but neither provides automatic, ongoing synchronization, like Azure File Sync. Which storage redundancy option provides the highest degree of durability, with 16 nines of durability? Correct answer: C. GeoZone Redundant. Storage explanation. GeoZone Redundant Storage, GZRS, offers the highest level of durability among Azure storage options. It combines the high availability provided by Zone Redundant Storage, ZRS, with protection from regional outages provided by Geo-Redundant Storage, GRS. This combination results in 16 nines, 99.9% of durability for your data, which is the highest offered by Azure Storage Services. Which Azure Storage Service supports big data analytics, as well as handling text and binary data types? Correct answer: A. Azure Blobs. Explanation. Azure Blob Storage is optimized for storing massive amounts of unstructured data, including text and binary data. It's particularly well suited for big data analytics scenarios, supporting services like Azure HD Insight, Azure Databricks, and Azure Synapse Analytics. While Azure Files is great for file shares and Azure Disks are used for VM storage, neither is specifically designed for big data analytics in the same way as Azure Blobs.